Hello, colleagues. My name is Evgeny Zhuk. I'm engineering manager at PAM Systems, and today we continue our talk about solid principles. Today we will talk about the third one, about Liskov substitution, and uh, let let's share my screen. Hope you see it. So. We already discussed single responsibility, open close principles, and that's the third one. Single responsibility was about how we should organize our source code according to the file systems, about grouping modules and so on. Open close it was about how to organize dependency management in our software projects, and Liskov substitution principle, it's about relations between different software entities. So let's dive a little to the history. In 1988, Barbara Liskov published in a scientific journal in the United States article where she declared this principle. I will read it. If for each object O1 for type S, there is an object O2 of type T, such that for all programs P defined in terms of T, the behavior of P is unchanged when O1 is substituted for O2. Then S is a subtype of T. Frankly speaking, for me, it's like flashback to the school when I learned geometry and all this stuff about theorems and proofs. So at least for me, more convenient to use the outcome of this principle, and it sounds like objects of a subclass should be replaceable with object of its subclasses, superclass, I'm sorry, without breaking the application. So for me, it's more clear, and that's frankly speaking correct. So nothing controversial between these two statements, and even in software design books like Clean Architecture, Clean Code, Robert Martin also use the outcome of this principle, but not the full declaration, because it's really something like math. Let's try to see on practice how to understand it. So for each objects like O1, O2, so let's imagine that we have some application with licenses. So we have two, personal license, business license, and both of them implement license interface with only one method like calc fee. The particular algorithm is hidden for us, but it doesn't matter. So both these classes implement the same license. Billing is our client system which use license, and with this interface it can use both personal license or business license without any problems. So according to the billing system, each object, each instance of personal license can be replaced with business license, and nothing will change. When I first time seen this diagram, I was wondered why this we have interface, not something like abstract class or maybe just a superclass like license. Why interface? So as we mentioned 2 times on previous sessions, we should always prefer I forgot the word. We should prefer composition over the inheritance. So why it's so important? So because when we use inheritance, we coupled our objects, our classes into the system, but we know that high tight coupling in system it's a bad thing, and this leads to problems with maintainability, with scalability, and so on. So it's just like one additional design principle. So always try to use composition over the inheritance. So that's exactly why here used interface, because frankly speaking, we always can replace interface with abstract class and most likely nothing will change. So why we should use abstract class instead of licenses. Let's move to the more or less practical examples of this LSP principle. About 10 years ago, I participated in one technical interview, and the interviewer asked me about OOP, and one of the questions was the next. So imagine you should create two classes, rectangle and square. Could you please organize them in terms of inheritance? So which class will be superclass, which subclass? I learned geometry in school, so for me it was quite easy answer. So I said it's obvious. So we know that square is particular case of rectangle. So rectangle should be a superclass, and square should inherit it. Great. Then he asked me to draw the diagram and try to implement these classes. I started something like this. That's not mine, but I draw something really, really similar to this. I created rectangle, two methods like set height, set width. And when I started square, I understand it's something wrong because at least one thing is different, that we should have different constructors for both of these classes. So square have only one parameter, but rectangle two. So that was the problem, and yeah, that's first time that I understood that solid it's important and we should inspect this. So frankly speaking, it's quite common task, and I saw it a few times on other interviews with different variations. With another variation, it's like dependencies between circle and ellipses. Logic absolutely the same. So let's dive to code a little and try to let's try to check how it can be implemented. So yeah, in this example, we create rectangle class with constructor with two arguments and two methods like set width and set height, and get area. Nothing special. Extends square from rectangle. As I said, we see the problem that problem number one, that we have only one parameter in constructor, but superclass use two. So it's kind of duplication here. Another thing, since we should follow the contract, and here in superclass we have set width, set height. In subclass, we should overload these two methods with this logic. So for square, height, and width, the same. So if somebody will change width, height also should be changed. And we inherit get area here. So we reuse this code. Inheritance, it's about reusability. So everything great. And here we have a problem. Somewhere in the application, we work with all classes as with rectangles, because, yeah, we know list of substitution principle, and it should be replaceable. So we work with superclass, with rectangle, and when we set width, it's incremented by 1, and under the hood, also height incremented by 1. And here, when we run this code, we will get an unexpected behavior. So for example, here we create a square with side equals to 5, then increase this height, and we expect here should be with 5 equals to 30 area, but in reality it will be 36. It's absolutely unexpected, and it's hard to catch this bug. How it should be fixed? Here, absolutely the same example as we saw previously with open-close principle. Again, we introduce just shape interface with get area method. Both rectangle and square implements this shape, and our client application depends on shape instead of rectangle. So in this case, everything compatible with Liskov substitution principle, also with open-close principle, and even with interface segregation principle. So no unexpected behavior, and we can see that the amount of code increased, and we don't reuse get area. So each class use their own get area method. So that's the, I would say, drawback of using composition over inheritance. So we sacrifice reusing with maintainability. So because we maintain code more often than write it, and based on this, it's more preferable to think about maintainability and I don't know, scalability in future, rather than some kind of reusability right now. And yeah, mostly application follows all solid principles, looks more redundant from code perspective than applications that not adopt all solid principles, but it's easy to maintain. Let's move to something more real. Again, it's a synthetic example, but it's a little bit closer to reality. The same situation as previous with payment. Now we have abstract class just to illustrate that it also works with not only interfaces, but with abstract and with abstract classes and even super classes as usual. We have two classes like credit card payment and PayPal payment. Both of them extends payment method. Two methods there, like process payment with different implementation for both. But in PayPal, we need additional functionality. So, for example, we need to initiate some kind of widgets and do some things in this method. In the client code, in this case, we need to add additional check for PayPal and invoke this specific logic. First of all, we can see that this code violates the open-close principle because we introduced new logic in one place of application and then should change something in another application. So it's not closed to the modification. That's first violation. Another thing, obviously, since the code depends on low-level implementation, it also violates dependency inversion principle. And that should indicate for us that almost 100% that Liskov substitution also will be violated. So in our case, it's also violated. Here, if we will run it, we see that this code will work, but it's not replaceable. So we cannot easily replace credit card, for example, with PayPal, because PayPal has additional logic. And to fix this, we need to extend our abstract class, add some additional method like initiate payment process. Credit card also should be extended to follow the contract because abstract class force us to implement it in each subclasses, these methods. Even in case we don't need this, we have to write something, for example, return null or something like this. But in client code, now everything correct. Both object replaceable, so we could use both of them, and nothing will produce unexpected actions. So yeah, we could replace vice versa there. Using interfaces, this code can be rewritten to more clear code, as for me. So we can create two separate interfaces like payment processors and processor, and payment initiator. And our classes like credit card payment and PayPal payment just implements both interfaces. So in case we need this, so for example, PayPal can implement both interfaces, but credit card can implement only one interface. So in client code, we replace dependence of one superclass. We replace it with dependence of different interfaces, and our code will be absolutely compatible with all solid principles. As we mentioned few times earlier. Solid, it's not only for OOP, but it's almost always compatible with all other paradigms. And I hear a lot that nowadays with React, Solid, it's not works and so on. Let's see on this example with React code. We see they're absolutely the same, and it's absolutely real code with some changes. So we have button in application. It's just a HTML button with on click, class names, and so on. Who familiar with React? I believe you saw this many times. Let's introduce high-ordered component. This high-ordered component will produce different types of button based on the type. Nothing special here, just add additional class name based on this strings and these class names. Also, this code can be more compatible with open-close principle, and this factory could be moved to another file and became more sophisticated. But to simplify this example, let's use it right there. High-ordered component, this produces 3 different buttons, like primary, danger, disabled, so on. And in our client code, we see all these 3 buttons. And you can see that all these buttons can be replaced with just button, with this one. And the application will work. Obviously, some behavior will be changed, but will be changed only UI. I mean only appearance. So only classes. But when we press on the button, it will work absolutely as previously, and all actions will be in place. So something will be changed, but in general, the application will work, and each button can be replaced easily with another buttons, or even with parent component, like with button. Let's summarize what we seen today. So Liskov substitution principle, it's mostly focused on relations between software entities and dictate us how to organize inheritance inside the software applications. And just keep in mind that each time when you inherit one class from another, double check, do you really need this? Or maybe it could be replaced with some interfaces and composition. Using an adoption Liskov substitution principle increases the system maintainability and reduce complexity by enforcing clear contracts between classes. So again, it's introduced and force us to use interfaces and high-level abstractions as a contract. And frankly speaking, I believe that interfaces and proper using of interfaces, it's key and real meaning of Solid. So that's Liskov substitutions show us how to use them. It was a surprise for me, but Liskov substitution principles simplify testing. About 6 years ago, on one of assessments, was introduced a thing that practical usage of Liskov substitution in JavaScript can be unit testing and using mocks as a subclasses. And frankly speaking, that's correct because our mocks, that's fully in unit tests, that's fully subclasses, and using mocks in tests should not break the application. And in case you use Liskov substitution principle properly, you can reuse your mocks. So you could write one mock and then use it in all tests required this particular superclass or interface. And as we seen, it's not only for object-oriented programming, it also works with React. It also works with API design. We haven't seen this on our session, but in case you will read a clear architecture book from Robert Martin, he illustrated it's quite clear. So using Liskov substitution as all solid principle will make your software more reliable, more maintainable, and more scalable. That's it. Thank you for watching me. And in case you have any questions about this topic or comments, please left your comments in YouTube. We will, with the team, we will read all comments, all questions, and all questions will be addressed on the special session after all sessions about Solid. That's it. Thank you, and have a good weekend. Bye.